it's crazy, but it's
You're watching Channel Z, the world's leading zombie apocalypse channel, broadcasting live from Studio Z.
Makes me act the way I do.
And hello, welcome to another very special episode of the Dr. Z Show on Channel Z. This is a special in bunker episode of the Dr. Z Show for the 2022 Zombie Apocalypse Medicine Meeting. As always, I am your host, Joe Alcock, MD. This apocalypse is heating up, and we have had to escape to a undisclosed bunker location. It's a little sterile. I'm used to there being a little more color, a little more blood, a little more body parts around me. And I see a message here from Christina. I'm concerned, she says. Where are you? Is it safe out there? We can't tell you where we are. We're gonna keep that at least secret. I do feel safe. I know that there's a lot going on. There may be hordes banging down the door, but I can't hear them. So I think that we're good. So we're gonna take this opportunity to discuss evolutionary medicine in the apocalypse. Today, I am joined by two very special guests. We have evolutionary anthropologist Ed Hagen. Welcome, Ed.
Thank you. Glad to be here.
He is one of the smartest and most innovative thinkers and writers in evolutionary medicine. We are very, very happy to have you to talk about today's topic, which involves drugs, of all things, and the evolution of drugs and drug taking. I also, to my right, we are very, very happy to have microbiome scholar Arek Rein Jungwirth. Thank you so much, Arek, for joining us. Now, Ed, you hail from, I believe, Oregon, somewhere in the Pacific Northwest?
Washington State.
See, I was close.
Yeah,
You're flying to Oregon today. So you live and work in Washington State, but you came to us by way of Brazil.
That's right.
Arek, how far were your travels?
So I came over from ASU. Right now I'm taking part in the Dr. Actipus lab, looking at microbes and behavior.
That's a very good place to be. So at Arizona State University. I guess we can disclose that we are still in the great state of Arizona. So hopefully there are no zombies listening. But for today's topic, both of you are going to help me explore this idea of microbiomes hijacking our bodies and our neurochemistry, and as important, the evolution of drug taking and why there are drugs in the first place. Before we plunge in, folks, I want you to remember you can send us comments. Feel free to share some love on the socials, smash that like button. But please, this is going to be an interactive conversation, and we're going to keep our eyes out for questions from humans, zombies that may be listening, etc. So yeah, smash that like button. So Ed, why did we evolve to take drugs? That's going to be our main question. What is up with that?
Yeah, so we have to kind of think, what are the common popular drugs? And they are nicotine, tobacco, caffeine, marijuana, cocaine, opium. And we look at those substances, they're all plant defensive chemicals. They all evolved in plants, like tobacco plants, marijuana plants, coca plants, to defend the plants from herbivores, from insect herbivores, from vertebrate herbivores. And they do so, by and large, by disrupting neural signaling in the herbivore. So they're basically toxins.
That's fascinating.
They're pesticides.
Pesticides, yeah. It occurs to me that I drank my fair share of the neurotoxic plant pesticide this morning in the form of coffee. It occurs to me, we ask our patients, we say, do you drink? Do you use recreational drugs, or are there any substances that you use? We ask about smoking. We don't ask about coffee drinking. Right. And of course, many of us are enjoying a morning cup of coffee. And really, as you say, this is a neurotoxic plant pesticide that we're taking into our bodies. So yeah, that's a different way of looking at it, isn't it?
Yeah. So we regularly consume plant pesticides. Caffeine is probably the most popular drug worldwide. Alcohol is an exception here. We'll maybe get to that a little bit later.
We'll definitely get to alcohol.
Yeah. So the question is, why are we consuming these plant pesticides? And that's been a big question. But the problem is people haven't really framed it as consuming pesticides. They framed it as consuming these recreational substances. And so our approach, by framing these drugs or really recognizing that their evolutionary roots are as evolved pesticides, we began to wonder if the benefit, that there might actually be some evolved benefit to consuming these substances.
Which is very different, I think, from the way that we typically approach this, right? The way that me, as I've gone through medical school, think about this. And I agree with you, Pam. You made the comment that people lie to their doctors about whether they take or use drugs. Most of us probably do, and without even thinking about it. As I mentioned, I think coffee is a drug, and certainly alcohol is something that patients typically will underestimate or underreport their use to docs.
Yeah, and if you had a can of Coke, you had a dose of caffeine.
You had a dose of caffeine, absolutely. So the way that doctors might learn about this is that we have these endogenous neurotransmitters. We've got nicotinic neurons in our bodies, and this is normal and good and healthy. And then because of our modern environment, in which we're able to flood our bodies with huge amounts of exogenous neurotransmitters in the form of tobacco, that's the problem. So it's really almost an idea that our bodies are mismatched for the environment that we find ourselves in. That's the evolutionary story that I have told my students before. So I think that's missing at least part of the picture, don't you?
I think it's really misleading, and we're really pushing back against this idea. So this story that you tell is called the hijack hypothesis. And this is the idea that, yes, we have all these neurotransmitter systems involving dopamine, serotonin, acetylcholine, and other neurotransmitters, the cannabinoid receptors, and so forth, and the opioid receptors. And that humans have, in recent times, just discovered that certain plants will trigger those systems and trigger reward circuitry in our brain. It makes us feel good. This is the standard story.
Right.
And then we get hooked on it. And it's a mismatch that we didn't have cigarettes during our evolution, and we didn't have bottles of wine, and we didn't have OxyContin.
Yeah.
And so we have culturally evolved production of substances that by accident make us feel good.
Right.
Now, the reason we really push back against this is that really depends on these substances being evolutionarily novel, that we didn't evolve
Yes.
With nicotine and cannabis and opium and cocaine. But that's basically false. We evolved as plant eaters.
We evolved with cocaine?
And we evolved with plant defensive chemicals. So our diets, since the beginning of time, almost literally, life on Earth, that any what we call heterotrophs, organisms that subsist by eating basically plants, have for 500 million years been consuming plants that have been producing defensive chemicals. And the defensive chemicals and then there's a huge variety of defensive chemicals that plants produce, but a large fraction of them defend the plants by interfering with animal nervous systems. They're basically neurotoxic pesticides. So from very early on in our evolution, we have been continuously exposed to an enormous variety of plant neurotoxic chemicals, not necessarily nicotine specifically or cocaine specifically or opium specifically, but a wide range of compounds that are attacking those exact same neurotransmitter systems.
Yeah.
So these are not evolutionarily novel in that broad sense. They are substances that we have been exposed to since the beginning of the evolution of animal life on Earth.
Does make me wonder who or which party evolved these substances first? Like where did they come from? And this brings me a little bit to you, Arek. Where do these chemicals come from? A lot of what we think of as human neurotransmitters, molecules that we use for our own bodies in terms of signaling. Some of them are also found in microbes, aren't they? And this leads to the possibility, as you've mentioned, and it's an area of your study, that microbes may actually that's probably the wrong word. They may have evolved in some ways to manipulate and hijack human neurotransmitters.
Absolutely. So, microbes can make a huge host of substances. Serotonin. They can, can control the way that we metabolize, essential amino acids like L-phenylalanine to make dopamine. They can produce all sorts of signaling molecules that interact with, say, our endocannabinoid system.
Cannabinoids.
Right.
Endo. So microbes make these little cannabis-like substances?
That's right.
Wow. So are the microbes causing us to crave chocolate, as Pamela says, or maybe even drugs?
It could be. One thing that we're interested in is, do microbes influence eating behavior in general? Can microbes make us eat more of certain foods that they like to digest?
And as we mentioned, if that's the case, that may be a partnership that happens in between mammal and microbe against plant. That if the microbe is inducing us to consume a certain plant food, right, that is a beneficial substrate for their fermentation and growth, that may benefit microbe and mammal to the detriment of the plant. It's just an interesting way of thinking about it. Brings us back to Ed's idea that, in fact, most plants don't want to be eaten, and have evolved all sorts of strategies to prevent themselves from becoming food, right? With a few exceptions.
With a few exceptions. So plants do produce fruits that contain a nice, nutritious reward for animals to disperse their seeds. And they also often produce nectars that are chock full of sugar, highly nutritious, again, inducing pollen dispersers, honeybees to disperse pollen. Interestingly, though, even those fruits and nectars often contain what we call plant secondary compounds. These are the plant pesticides, and so the story is even a little more complex.
Think of things that I might think of as being a good thing: flavonoids, secondary plant compounds that are in like cranberry juice or resveratrol, which is in grape juice or wine.
Right.
You're saying that that's a pesticide too?
It's possible that the botanists are still trying to work out why are these fruits that are meant to entice animals to disperse them chock full of what look to be substances that are chemically similar to. So in fact, you can even find nicotine in some of these things. Now, some of the ideas is that fruits take a time to ripe, so you don't want any animal to eat them prior to the time when they're ready to be dispersed. So unripe fruits are pretty darn toxic. And then they transition.
Have you ever tasted an unripe persimmon?
I haven't, but I can guess it's not.
It's really astringent.
Yeah.
Yeah. So we're getting some good comments here. Who's in charge, me or the microbes?
Right.
I think I saw a comment from Nicole asking whether the microbes could induce us to eat specific kinds of foods, control our cravings. Maybe if I'm craving fruit, and fruits are also colonized by microbes. Right. I wonder if there could be something to that idea. You thought about that?
I have not thought about that.
But I bet Arek has.
Yeah, I have. So one way that microbes might be able to influence our eating behavior is through controlling these hunger and satiety hormones. So these are hormones that can make us more hungry or less hungry. But it also looks like these hormones can actually control what kinds of foods we're preferring. So that hunger hormone ghrelin makes us lean more towards highly palatable foods, to prefer sweet tastes. There's some evidence on that, whereas satiety hormones like GLP-1 can actually push us in the other direction. We might lean more towards maybe some more plant-based foods that are not as exciting, but they are still good. Yeah.
To the point that we brought up in yesterday's Dr. Zed show about the fact that there are a lot of neurochemicals in certain fermented foods. These are the foods that I crave. I love a lot of fermented foods. I love cheeses and a good glass of wine, chocolate. It seems to me all the good things somehow involve microbes, their products, and it's not completely unreasonable to think that they may be affecting our food cravings in one way or another. But it occurs to me, Ed, that not all humans like these plant pesticides. There's certain categories of humans that don't.
Yeah. So as we were talking about earlier, these things are plant pesticides, and they interfere with brain development. So when your brain is developing, all of the neural circuitry that your brain uses to function as an adult is also playing critical roles in guiding development, the proper development of your brain. So if you're exposing a developing brain to something like nicotine or THC or cocaine, you're disrupting the neural circuitry that's critical to
Don't
brain
give
development.
your children cocaine.
That's right.
That's,
Don't do
that's
it.
That's
Don't give them
a
cigarettes.
free public service announcement here.
Right. Don't
Dr.
serve
Zed
them even a nice glass of wine. It's a bad idea. So our hypothesis is that kids just don't like these things because they have evolved to avoid plant pesticides.
They clearly have an aversion.
They have a strong aversion. And the reason is that they don't want to disrupt their, again, not consciously, but they've evolved to just find them very aversive and avoid them to avoid disrupting brain development.
And so, but how do these young mammals or young animals, how do they actually know what substances might be toxic in the way you're saying?
That's a great question.
Yeah, great question. And there's probably a number of ways. We have on our tongues what are called bitter taste receptors, the T2Rs. We have a wide variety of them, and they're able to detect. They're activated by a wide range of what we call xenobiotic substances or plant toxins, basically. And so they taste bitter. Nicotine, all recreational drugs taste bitter. Nicotine tastes bitter. Cocaine tastes bitter. Opioids taste bitter. These are all bitter tasting substances.
Do kids have more of those sensors on their tongues than we adults?
And there's increasing evidence that kids are more bitter taste sensitive, but they can taste lower concentrations. So they do these concentration studies. They dilute. When can you not taste it? Kids can continue tasting beyond what can adults do.
So it looks like they're biologically different.
Yeah, they're biologically different and predisposed to be able to detect smaller quantities of these things and find them more aversive. And these bitter taste receptors are actually expressed in other tissues beyond our tongues. They're expressed in the gut and airways and other tissues. So there may be you're probably detecting these toxins, not just in your tongue when you can spit it out. That would be the best time. But if it gets into your gut, they're probably getting activated there and may trigger vomiting or other kinds of reactions as well. So we have a whole host of toxin defense mechanisms that look to be upregulated in kids and really prevent them from using these things.
I had read that there are taste receptors even in your blood vessels, and they're responsive to signals from the microbiome, to your point, Arek. And I saw a question, I think, earlier from Baba Brinkman about whether we can use microbes to release drugs into our system continuously, maybe not continuously unless they're living in our bodies continuously. There's some people who are auto fermenters. It's this idea that you have an auto brewery. In certain individuals, they're just making alcohol and be drunk because of microbes inside their own bodies. So that'd be an example of that, Baba. Some court cases. But there's this idea of psychobiotics, that we can actually have neuroactive microbes to treat certain mental conditions, things like depression and anxiety. That's right.
And we think that this may also explain why women use fewer drugs than men. That adult women often avoid drugs more than men. And again, it's because women might be pregnant, they might get pregnant, they might be nursing, and so they're not trying to protect their own brain development, but potentially protect the development of the fetal brain.
But for those of us that are not going to get pregnant, we're essentially disposable if we're no longer developing, so we can just consume these substances in large quantities, right? But it's a absolutely kind of night and day kind of a thing. You've described this in your own research, that at the time of adolescence, there's a switch. And if you think about the time when you first drank a cup of coffee and didn't automatically spit it out, and kids almost uniformly are not interested in coffee once it's massively sweetened. And for me, that was when I was in medical school. And it was just the stage in my life when, post-adolescence, all of a sudden that stuff started tasting really, really good. And now I drink it every day. Yeah.
What we see in global studies is that everybody transitions to drug use sometime between age 10 and 20. So from 0 to 10, basically nobody uses drugs. And then from 10 to 20, by the time you're 20 years old, everybody is using some drug, be it caffeine, coffee, tea, nicotine, marijuana, alcohol, whatever it might be.
Why?
And the question is
what is
why?
Up with that?
So we have a really good reason why we should avoid. So we know why people avoid these things.
Pregnant in utero,
fetal development,
Fetal
brain
development,
development, what we
the
call
little
fetal
kids.
protection hypothesis, little kids. But why this switch-like transition to the use of drugs? And our hypothesis is that these drugs are providing the same benefits to us as they evolved to provide to plants. So plants are eaten by a variety of plant consumers, from bacteria to parasites to vertebrates. And these substances evolved to harm those herbivores to deter them from eating the plant.
Okay.
And basically, we are eaten by the same things that eat plants: bacteria, protozoas,
Hopefully not
parasites.
insects.
We are eaten by insects, mosquitoes.
Oh my God, you're right.
Yeah, so or arthropods. So we're eaten by the same
Maybe this
categories.
is the idea behind consuming lots of garlic to fend off mosquitoes.
Yeah, and maybe smoking does too. So
What?
because there's a lot of nicotine in tobacco smoke, so it may actually protect you from these hematophagous insects.
Have you done those studies?
I have not.
We got to do those studies.
Yeah, we got to do those studies.
You're in grad school. Let's we should be designing
firing up some smokes here. So our argument is that we evolved to transition to using these substances to protect us from the same broad categories of predators that are also going to eat plants. Because these things, nicotine is going to kill our parasites, cannabis is going to kill our parasites, cocaine is going to kill our parasites in the same way that it kills the parasites of plants.
So Ed, are you saying
Fascinating.
these things make us taste bitter to mosquitoes?
They might, yeah, they might well make us taste bitter to mosquitoes and other parasites. So we evolved.
They must have better taste sensors.
They do have better taste sensors.
Right?
They probably do.
How about tapeworms? Do they have?
Tapeworms, yeah. So tapeworms. So let's just kind of focus on nicotine here for a second. One of the world's most popular drugs. It attacks the acetylcholine signaling system. This is how your brain controls your muscles, including your heart and your diaphragm. It's an extremely potent neurotoxin. But it also, most humans for most of human evolutionary history were infected with intestinal worms. And these worms also have acetylcholine signaling systems and neuromuscular junctions. And so if you flood your body with nicotine, it could possibly be that it's going to be more harmful to the worms than it is to you. And we actually have evidence that tobacco and nicotine, in fact, farmers for decades dewormed livestock using nicotine.
I didn't know that.
Yeah, until the development of modern anthelmintics, nicotine was one of the major deworming compounds. And actually, in many parts of the world today where they don't have access to these drugs, they'll take tobacco and kind of get a big bucket of water and put a bunch of tobacco leaves in it and feed it to their goats or pigs, and it deworms them like that. If it doesn't kill them.
Now, again, I am my day job. I'm an emergency physician. We're not advocating
don't
smoking,
do this.
right? We're not advocating tobacco use.
And don't chug nicotine.
It is one of the worst things you can do for lifespan, and it causes all kinds of chronic health issues. But the flip side is that there's a bigger part of the story, one that involves evolution on this planet and how we interact with microbes in our bodies. So that is fascinating. It does make me wonder whether, I just got distracted by this comment here. Does the taste of human blood make mosquitoes' tongue neurons light up like fireworks? I bet it does. That's
Sounds plausible.
Or the little taste receptors on the Teniasolium tapeworm, right? It's got to be something similar, right? So it makes me wonder: are people in more parasitized areas more likely to smoke?
Yeah, we've been looking at that, and one of our studies is with Aka hunter-gatherers of the Central African Republic, and 95% of the men smoke, and 100% of the men are infected with worms. So it's got one of the highest
100%.
rates of worm infections, and it's also got one of the world's highest rates of tobacco use and cannabis use. So about 70% of the guys use cannabis. So that intrigued us that one of the most parasitized populations is also one of the heaviest tobacco using populations. And we in fact have evidence that the heaviest smokers have the fewest worms in that population.
That's pretty good evidence.
We're getting there.
Yeah,
So
pretty good evidence.
Yeah.
So we have, I think, time for a few more topics. One is this idea, Arek, that we've discussed, that if, and still is kind of an if our composition of our guts, our microbiomes are capable of manipulating our neurochemistry and inducing cravings for the foods that they prefer to use as a carbon source and a growth substrate. Is it possible that there may be certain drugs that benefit certain microbes, and those could be involved in cravings for those drugs? So is the microbiome involved in addiction? Have you thought about that?
Yeah, I have. So one way that these drugs could influence the gut microbiome is, again, like we talked about earlier, to control motility.
You're talking about the guts and our guts moving?
Yeah. So whether the gut's moving, whether it's flushing out the microbes that are there, or is it holding on to them? And what's interesting is we see the drugs can affect this motility in opposite ways. So nicotine or caffeine from coffee is going to increase that motility.
I know what it does to me.
Yes, potentially flushing these things out. And some people have looked at tobacco use, and not just in worms, but also in inflammatory bowel disease like ulcerative colitis. And there seems to be some association there where in some cases the people who are using tobacco might have less ulcerative colitis. But then there's the flip side of that could be opioids, and a lot of people actually treat inflammatory bowel diseases with opioids to help them deal with the pain, or sometimes to help them deal with diarrhea.
But it comes with a cost.
And it's controversial because there's some studies that show it might have some negative effects on a longer term time scale. And so that would be one example of different drugs having actually a different effect on the good bugs or the bad bugs. That was a similar question I had for you, Ed. There's all these different plants, maybe having, a lot of them could be toxic. Are they having, do they have different strategies for getting bugs, like insects or herbivores? Do they have different strategies for getting herbivores or bugs to leave them alone? Some of them might be sedatives, or some of them might be stimulants that are actually getting these animals to run away and go somewhere else. What do you think?
Yeah, so there's basically evidence that plants have evolved compounds to interfere with every single aspect of cellular signaling and neural signaling. So neurotransmitter release, neurotransmitter uptake, neurotransmitter binding, every stage of neural signaling there's some plant toxin that will interfere with it in some way. So the potential behavioral manifestations and neurophysiological manifestations are very, very diverse. But the take-home message here is that plants are interfering with the evolved functions of the nervous system in insects and vertebrates in just about every way imaginable.
Every way imaginable.
Yeah.
Wow. And we take advantage of that both in potentially seeking out psychobiotics and our neurotoxic plant pesticides that we use, that they may have some health benefits. And we also, in medicine, right? And in traditional medical societies and traditions, there is a lot of seeking out and prescribing these toxic plants, isn't there?
Yeah. So about half of our medicines are plant-based or plant-inspired because plants are evolving compounds that manipulate cellular signaling, but then we can co-opt those to manipulate those cellular pathways when we need to manipulate a particular cellular signaling pathway for some medical benefit. So there's huge efforts by the pharmaceutical industry to screen plant compounds, looking for compounds that might be able to treat particular diseases that result from some problem in cellular signaling.
A thin line between plant benefit and plant toxin.
Exactly.
Exactly. Well, this has been a great conversation. I really appreciate the insights that we've had from both of you, Ed and Arek. What a wonderful apocalyptic discussion we've had in our bunker here. Again, hopefully safe from the zombie hordes. But thanks again for a truly apocalyptic discussion, and we will meet you next time for our next Dr. Zed and for more ZAM 2022 programming. Until next time, be safe.
And if the whole world says that we're crazy,